Good evening, popular astronomers. Back in a couple of minutes. The official show starts at 8. Good evening, popular astronomers. Welcome. It's really weird today because I usually do this show on a Friday and I've been convinced it was Friday all day today. I've made some terrible administrative errors in my life today, thinking it was Friday, signing off emails like have a nice weekend and emailing people asking them what they're doing tomorrow. That's no problem. I've always got the Friday feeling when I do Popastro Live. So let's start the weekend early. We're going to celebrate because a comet is here. How fantastic is that? Excuse me, let me just turn my light on. So, oh, there we go. That's better. Now I am better lit. How are you this evening? For the first time in maybe a couple of weeks, the sun is shining here on Anglesey. As I always say, we are very far out west. Although we've got brilliant dark skies, we are also prone to a lot of storms and beastly westerly winds. So we've been getting hammered here this past couple of weeks. But finally, has a high pressure arrived? Is the weather just coming in from the west now and spreading over the west of the UK? Over in that direction is Snowdonia. So hopefully the cloak of cloud is moving away and bringing a clear night behind it. And who knows what we're going to see? Well, hopefully in a little moment, you're going to know what is in the sky over the next couple of weeks. So this is Popastro Live. It's our weekly show. We have a different special each week. Tonight it is a Comet special, with a little soupçon of Jupiter and Saturn. And we love your audience participation on this show. So please start commenting. And do you know what we would absolutely love? The SPA is a voluntary organization, and every 2 months we have a brilliant magazine, we have meetings and all of the benefits that happen when you become a member. But it's really important for us that we keep new blood coming into the new blood. That sounds a bit sinister. New blood, fresh blood into the SPA. So please hit the share button on this video and share it so all of your Astro pals and even your not so Astro pals can see the video and give it a like as well, because, you know, astronomy is for everybody. So give it a share onto your timeline, tell people to watch us, and let's get the audience numbers swollen, and hopefully get some new members as well. This show is really to educate everybody of any level in astronomy. So share it with the world and get people on board with the SPA. That'd be fantastic. Right, we've got 9 comments. Thank goodness for Facebook pop-ups. Hi, Vicky. Nice view of your refractor. Thank you, Alan. This thing is a beast, and it might be coming out tonight, Alan. It's amazing. This is the new Celestron Star Sense, which you slot a smartphone in, and I reckon with the app technology, you can get to any object in 10 seconds. I reckon it might be the world's fastest telescope. Excuse me, my phone is ringing. Oh, excuse me. I must always remember to switch my phone off. There we go. Okay, so this is my Celestron, and it's a beast. It uses arrows on the screen of the app to whiz it around the sky in a heartbeat, 10 seconds to any target. So hello, Paulina, one of our regulars. Really nice to see you here this evening. Simon. Hi, Simon. Hopefully no clouds tomorrow morning. I know we're all praying. It's hopefully, hello, Christopher, where it's just past midday in Arizona. Now, Arizona is on my timeline a lot at the moment because it's the yearly anniversary of when it should be Space Fest, which is the big, massive space gathering at Star Pass Resort in Tucson, which I went to and hosted Brian Cox onto stage because I was a compare. One of the showbiz astronomy moments of my life. Going to be upset tomorrow when I have to go to work. Oh, yeah. Thursday equals Friday. Yeah, absolutely. Hello, Michael Barrett. Good evening. And hello from Abingdon, Madeleine, with a nice cat for a face. Great stuff. So let's have a look who we have got on the show this evening. Well, first of all, plug the mug. What colour is tonight's lipstick? It's gone. Usually I've got lipstick stains. I do only use this mug once a week. It's a special mug, so I drink a bit out of it and then it kind of goes to get washed up. And we'll frequently have last week's lipstick on it because sometimes the boyfriend misses it. So stay hydrated with the Popastro mug. Go to our shop on popastro.com. We have got loads of new merchandise. Paul Sutherland has been working hard coming up with punny mug puns to entertain you every time you take a sip of your favourite beverage. The current favourite is Astronomy is Looking Up. And ain't that just the truth? So I can't make tomorrow's show because I'm doing it tonight. And my excuse is I'm actually going to the moon. No, I'm not really. I make videos for a living, and I've got my first outside commission in 4 months. I'm filming a band. So tomorrow night, I'm otherwise engaged, and that's why it is tonight instead of Friday. But I'm excited. I've got work. I'm allowed back out into the back into the wild. It's like I put a radio collar on me and make sure I don't go too far away and track me. So on tonight's show, we have got prize-winning planetary photographer Martin Lewis, who will be explaining how to use an atmospheric dispersion corrector to improve our photos of Jupiter and Saturn. We've also got Colin Snodgrass, who is planning an ESA probe to intercept a pristine comet as yet undiscovered. And also joining us in a little bit is prolific observer Dave Eagle, who will be racing over from his virtual astronomy club studio. So when was the last time you saw the sky? An amazing thing happened the other night. I woke up at about midnight and I could see Saturn and Jupiter. And I showed the boyfriend Saturn and Jupiter for the first time in his life through my telescope. So July is a great time to view Jupiter and Saturn, but both of these planets currently sit well below the ecliptic, so they never really get that high up. Jupiter reaches opposition sometime next week on the 14th of July, so it will be visible for all of a short summer night, but only climbs to around 16 degrees of elevation, which is about 1 potato, 2 potato. That's 10 degrees when you hold your fist at arm's length, so it's 1.5 fists. Maybe that is about 15. Yeah, so it's going to be over there, quite low, and you're throwing fists at the sky. It will show a beautiful 48 arc second disk shining at magnitude -2.8, so it will be obvious and worth seeking out, although the low elevation may require prolonged observation to pick out all of its details. Couldn't really see the spot on that. You could just about see some banding on it, but we got all 4 of the Galilean satellites the other night. Saturn follows closely behind Jupiter, reaching its own opposition on 20th of July, shining at magnitude plus 0.2. And with its beautiful rings, it looks like an aeroplane dive bombing at the minute. Saturn does. It's giving us a full frontal. The ring system is tilted 21.7 degrees towards us. So throughout the period, it will be fascinating to switch between the two targets. It's really good. They're pretty much next to each other. Just a tiny little swivel of the telescope alternating between the two. What an eyeful. And it occurs to me, the first time you ever show anybody Saturn down a telescope, it's a bit like seeing a film star. You've only ever seen Saturn on TV and in pictures, and suddenly it is there in front of your eyeball. And the wonder and the delight that people get when they see film star Saturn for the first time. But don't you ever think that sometimes looking down an eyepiece like that is a little bit like looking down a microscope? You're looking at tiny things, and it's very similar to a microscope, except the universe is your Petri dish. So I likened it the other night that actually when you're looking at Saturn, it's actually a little bit kind of like looking like Marilyn Monroe down a microscope. And hopefully in a moment, we will have Martin here to help us improve your views of these beautiful planets. Let's see if he's online. He's not here. Come on, Mr. Martin. Let me just check. Just let me check. Martin. Hey, Martin. Okay, so I'm just going to invite Martin to the chat. Apparently my invite hasn't gone out. Invite. Here we are. So with a bit of luck, I might even see a comet right now. Here we go. Great. Okay, so let's see who's commenting. Hello from Scotland, John Mitten. Hello, John. What's that on your profile picture? Just trying to have a look. You look like you're out somewhere very nice. My mug only used for hot chocolate after observing. Michael, tell me what brand of hot chocolate you use, please, because I don't really have much success with it, to be honest. Hi, from Tucson at 32 degrees north, both Jupiter. So when I lived in Ibiza, they called it Jupiter. Jupiter and Saturn are quite high up, and there have been very few clouds since April. Maybe Tucson and the UK need to do an exchange program and swap slightly for a couple of months so we can exchange skies for a bit. We would love to have some of the clear skies of Arizona. And hello, Gillian. Hi from Cambridgeshire at last. Lovely picture of the full moon there that you've got there, Gillian. And Sandra Grace is saying hello as well. One of our newest members. I've been saying this for a while now. I need to drop the fact that you're a new member, Sandra. And but thank you very much for joining us and becoming an SPA member. So that is all very good stuff. We're just waiting for Martin to join us. I think he's just getting his technology into shape. And then we have got two comet experts coming on, and we're going to be playing a game. Now, a couple of weeks ago, we had Luke Jeremon, who is creator of Museum of the Moon. Here's Martin joining us right now, actually. So we had Luke Jeremon, who's creator of Museum of the Moon, and I had to think of some interesting game to play, and we played a game of crater or potato. Was it a crater on the moon or was it a potato? So coming up in a couple of minutes after Martin has done his little presentation, we're going to be playing a game very similar, and it's going to be something that rhymes with comet. What could it be? Paul Sutherland will be quaking in his boots in case I do comet or vomit, which I've been forbidden from doing. Don't worry, Paul, I've come up with a much better idea. Okay, Martin, we are coming over to you any moment now. Let's put your little banner on. Here he comes. 3, 2, 1.
Hi.
Hello, Martin.
Hi.
Hey, how are you?
Very well, thank you, Vicky. How are you?
Very good. Good. Now the tech is working. We had a little dress rehearsal yesterday, didn't we?
Excellent. Yes. Yeah,
excellent.
Finally got there in the end. Cracked the technical problems.
Cracked the technical problems.
Hopefully this will go smoothly.
Yeah, as smooth as that Comet NEOWISE jetting through the vacuum. What do you think?
Yeah, terrific comet. Haven't seen it yet myself. Weather's hasn't been so good the last few days. Mm-hmm. But over the weekend, I think it's now gone circumpolar, which means it doesn't set. And hopefully maybe tomorrow night or Saturday night, maybe Sunday night. Weather's looking good, and I think there's a chance of seeing it around about midnight. I think
Right.
very low in the north sky, below the bright star Capella. So you look directly north, and around about midnight, a pair of binoculars will help, and you need a clear northern horizon.
Oh, I'm just looking at the big mound that I've got outside my house in a northerly direction. How many degrees? Oh, hello. How many degrees is it high?
It'll only be a few degrees high, I think. Maybe 5 degrees, possibly
Okay.
less. So you do need a very low northern horizon to get a chance of seeing it. As the night goes on, it will rise, though. So, and then in a few days' time, towards the middle of next week, towards the end of next week, it'll be significantly higher in the evening sky. So for a lot of people, that will be the best chance to get a decent view of it.
I'm just looking out my window at the minute, wondering what my chances are. Or should I disrupt my sleep pattern, do you think, for it in the next couple of nights? Or should I wait until it's a bit easier to see? That's a dilemma.
I would always take the first opportunity you can get.
That's so true.
Yeah, otherwise you never know what might happen. So
sure.
I'd go for it.
Okay, excellent. All right, I have your permission to stay up late and disturb my boyfriend by coming in at 3 a.m. all excited, jumping on the bed. I've seen a comet. Paulina Morton is asking, how are you, Martin?
Very well, thank you. Yes, and looking forward to giving a short presentation about atmospheric dispersion correctors.
Yeah, so not particularly comet themed this evening. Oh, Bath astronomers are saying set the alarm clock. Yeah, that's very true. So not quite comets, but it is related to what is in the sky at the minute when you're outside looking at the comet.
Yes. So it's about viewing Jupiter and Saturn, which are coming into opposition this month. So they'll be at their nearest to Earth and brightest. I think Jupiter is the 14th of July and Saturn on the 20th of July.
Okay, so shall we do what we rehearsed in the rehearsal and share the screen?
Right, let's give it a go.
Let's see. Oh, and Kath Adams is saying hello.
Is that working? Are you seeing?
Oh, here it comes. Okay, so it's going to add to the stream now. Okay, so I will step back for 10 minutes while you go through your presentation.
Okay, all right. Give me a shout if it falls on its face.
I'm sure it'll be brilliant. Having had a sneak preview yesterday, this is a really interesting presentation to improve your views of Jupiter and Saturn. So let's go.
Great. Okay, so this is a talk about atmospheric dispersion and what to do about it. So what is atmospheric dispersion?
Oh, could you just click the full screen button, please, on your PowerPoint?
Let's go back. Let me stop sharing and then share again. Let's try. Has that worked? Hello? Hello?
Yeah. Oh no. It's the Doctor Who TARDIS has opened up. Yeah. The first try was the good one. Yeah, it was.
Let's try it again.
We nearly fell down a Microsoft wormhole.
That worked yesterday, and then. So, can you see that?
I can. It's requesting access, but it's not full screen yet. So I think you need to make your presentation full screen.
All right, I have. Don't know why it's doing that. So I'm making it full screen.
Okay, let's have a look. Oh, it's not full screen. Do you want to try again?
Third time lucky.
1, 2, 3.
Right. Entire screen. Allow. Right.
There it is. Don't touch
Right.
anything. It's there. Let's go.
Right. Okay, let's go. So, as I said earlier, Jupiter and Saturn both come into opposition this month. And if you want good views of them, you should consider buying an atmospheric dispersion corrector. So why do I say that? Well, these are the altitudes of Jupiter and Saturn this year and coming years. And you can see that both Jupiter and Saturn are very low in the sky at the moment. And that's because they are about as far south in the sky as they can go, about as far south of the celestial equator as the ecliptic goes. So Jupiter will rise no more than 16 degrees above the horizon when it's at its highest, which at opposition night will be at 1 o'clock in the morning. So that is midnight GMT. And Saturn only half a degree above that when it reaches opposition 6 days later. And they're very close in opposition because they're actually pretty close in the sky. They're not too far apart at all. And oh, why has that done that? There we are. And actually on December the 21st, they will be extremely close to each other, which will be a very impressive sight just shortly after sunset in the southwest sky. So being very low in the sky, it means you're looking through a much greater thickness of atmosphere, and the chances of getting steady views are reduced. Because you're looking through a lot of atmosphere, you're then subject to the disturbing effects of the atmosphere, which causes a loss of resolution. So if you're looking at it through a telescope, you might see quite shimmery views because they're so low. And also you will lose light due to atmospheric absorption. But even if you get really steady and transparent skies, low altitude objects suffer from an effect called atmospheric dispersion, and that dramatically affects what details you can see. So light from an object low in the sky, when it hits the atmosphere, gets bent, and the amount it gets bent depends on the color of the light. So you can see in this schematic, the altitude of Saturn is raised slightly by that bending or refraction effect, and the amount it's lifted depends on the color. So it's lifted the most by the blue because there's the most refraction in the blue end of the spectrum and the least in the red. So what happens is Saturn, nice sharp Saturn, gets split up in and smeared vertically, and you end up with color fringing. And you get the same thing with stars. So here's Polaris at an altitude of 52 degrees. So this is a photo that I took a few years back where I haven't aligned the colors, and you can see that the normally white star is actually split into a little rainbow, a little vertical rainbow. So you get the same thing with planets, and even if you try and match up the colors. So here's an image of Saturn taken in 2016. Saturn was 17 degrees high. On the left hand side, I've made no attempt to align the colors. This is with a color camera, and you can see the color fringing there, blue at the top and red at the bottom. In the right hand side, when you're doing your processing, you can realign those color channels, the red, the green, the blue, and try and line them up, and that's partly successful. So on the left hand side and right hand side, you can see Cassini's division there, reasonably sharp, but at the top and the bottom you've got a lot of smearing, and that's because within each color you get separation. So blue isn't a single wavelength, neither is red or green. It's a band of wavelengths, and you get this dispersion effect within each band. So what can you do about it? Fortunately, there is a device on the market called an ADC, or an atmospheric dispersion corrector. There's quite a few out there. ZWO do one, Altair Astro, Piero Astro, and they're the price of a premium eyepiece there. So what's in one of these? The key thing, and you might be able to see these levers on the bottom one there sticking out. Each lever controls a prism, and on the inside they look like that. So at the top you can see the split light from your planet or star spread into a little spectrum. But if you use prisms, two thin prisms at the bottom, which are adjustable, then you can compensate for that and produce a dispersion effect that almost exactly cancels out the dispersion introduced by the atmosphere. So it recombines the colors. That's what one looks like in the wild. So you can see at the top the planetary imaging camera. This is one from the imaging source. Then in the middle, the filter block. This is a custom filter block. Allows me to put different types of filters in there. I'm just using one there to block the infrared and just let the red, the green and the blue through. And then at the bottom with the levers and the graduations there is my atmospheric dispersion corrector. And that plugs into my Barlow, my magnifier. So as we saw before, here is Saturn on the left. As it comes, as it's imaged on the right, I've aligned in registacks, and then with an atmospheric dispersion corrector, you can see the dramatic improvement in resolution that you get. It really is significant, and you can see how the Cassini division, which was only just visible left and right, is now visible all the way around the disk. So here's an image taken of Saturn in, oh, sorry, I've missed a shot. There we go. Here's another one showing the same sort of thing from last year when Saturn was only 16 degrees high. And again, you see that significant improvement by the use of the ADC. And then here's an image from September last year, taken from my back garden in St Albans, showing significant detail. You can see the polar hexagon there at the bottom, and you can see Encke division, this very fine division, just extreme light right and extreme left, which is a really challenging target for planetary imagers. And it's transformational, the atmospheric dispersion corrector. There was a time not so long ago when if planets were below 35 degrees, you just didn't bother imaging them because atmospheric dispersion caused such a problem. But fortunately, those days are over. And you can find out more about atmospheric dispersion correctors by visiting my website. I've got a web page there under equipment, atmospheric dispersion correctors, and that tells you all about them and how to use them, how to set them up, and lots of hints and tips. So hopefully you found that interesting. Back to you, Vicky.
That was really good. And so could I put one on this then?
Yeah, certainly. Yeah, no problem. They'll go on any telescope, and they're not just for images. They are for visual. You can see that fringe view. That's the view that you would get naked eye. To some degree, your brain is able to filter the view, and so it doesn't look quite as bad as I showed there. But yeah, visually, an ADC will dramatically improve your view as much as it will with imaging. So Michael Barrett's asked the question there, do ADCs work with ordinary eyepieces? Yes, they do. One of the issues may be the inward travel, because it introduces extra length. You might have to move the eyepiece in a bit to get correct focus. But
Thank you, Martin. That was an excellent, outstanding talk about something that, as a complete novice astronomer, didn't even know existed. So that's absolutely fantastic. So a few weeks, I've got a challenge for you now. A few weeks ago, we played crater or potato. There's like 3 trillion comets on craters on the moon, and 4,000 varieties of potato, and it's actually quite hard to guess whether one name is a crater or potato. I've been told I'm not allowed to play Comet or Vomit, so I've got to play Comet or Bonnet instead.
Right.
So I've scoured all the different headwear types and all the different comets, and I'm going to read out 4 to you, and you can tell me whether you think it's a comet or a bonnet. It's devastatingly simple. Right, so here's yours. Okay, is it a comet or is it a bonnet? Kevin Huller, comet or bonnet?
Bonnet.
Congratulations.
Hey.
It's the kind of pirate tricorn hat.
Oh, right, okay.
What about Saturno?
Bonnet.
You are correct. It's worn by the Catholic clergy, and it is pleasingly reminiscent of Saturn. It's actually, of all the hats I would like that resemble a planet, it would be that one. And what about Tubiolo?
Bonnet again.
You are wrong. It's a 2005 Jupiter family comet. So there we go. You got 2 out of 3, Martin. Thank you for playing. The prize is on its way. You've won a comet. Well, I hope you have a fantastic weekend. It's not Friday. I've been keep on thinking it's Friday. I've had the Friday feeling because this is usually on a Friday night. So
yeah.
It's been a pleasure. Thank you very much for your time, Martin.
All right. Thanks for inviting me. And get out and look for that comet.
First one to spot it wins a hat. See you later.
Bye.
Bye. Great stuff. Okay, so it's the Popastro Live Comet Special. Coming up now, we have got Colin Snodgrass. So let's get Colin on. Coming to you in 3, 2, 1, Colin. Hello.
Hi.
Oh, you're there. Good. I thought the sound wasn't working. How are you?
Yeah.
Good to speak to you.
I'm good. Yeah.
Thank you for giving up your evening to come on Pop Astro Live. It's most appreciated.
No problem.
So, whereabouts are you tonight, Colin?
I'm at home in Edinburgh. So I'm based at Edinburgh University and at the Royal Observatory, Edinburgh. But at the moment, based in my home office, like most of us. So.
Are you looking, did you find like when you first started working from home, it was like, this is amazing. I can work in my pajamas. Why did I ever go to the office in the first place? And now after 4 months of it, it's like, I really need to get out of this box room.
Yeah, definitely could do with getting back in the office and seeing people again more than anything. Yeah, it's, but yeah, it's an easier, astronomy is an easier job to do from home than some things.
Gosh.
A bit challenging with observatories closed.
So you are planning an ESA probe to intercept a pristine comet as yet undiscovered. And the way I've kind of got it in my head after learning a little bit about it last night, Comet Interceptor is going to be a bit like in the American movies where the police hide behind a billboard waiting for a speeding car to go past. And then once the car goes past, the cops are on the tail. Is that what it's going to be like?
It's something like that, yes. So this is, the idea of this is to go and see a comet that's coming into the inner solar system for the very first time. So something that's not seen the heat of the sun in the way that all of the comets we visited with spacecraft so far have. But to do that, you've got to plan and build a mission when you don't know what the target is, and then launch this, wait in space until you see a comet coming in the right direction that you can get in the way of. Yes. So
the comet is going to whiz past. The cops are waiting behind the billboard, except the billboard is a Lagrange point. Is that where it's going to be hovering? And I do have a lovely vision. I have a lovely vision now of Comet Interceptor wearing a mirrored shades like an American cop. But please tell us all about it. First of all, tell us about the mission, and then we'll move on to the latest comet that we can see.
Yeah, so Comet Interceptor is, as I said, it follows on from missions like Rosetta, which was the big European mission that we had in the past few years, where we had the first landing on a comet, and the first time we actually went into orbit around a comet and studied 67P Churyumov-Gerasimenko in great detail. Comet Interceptor is quite different from that. It's a much smaller class of mission. It's not the same scale of project as Rosetta. But it does something that's a bit unique in that it goes to a comet that we don't yet know. So Rosetta's comet is a Jupiter family comet. It's on a short period orbit, so it comes past the sun every 6 years. And one of the things we learned with Rosetta is actually the surface of 67P is quite evolved and quite changed by all these encounters with the sun. And so we wanted to go and see what a really pristine comet, something that's left over from the formation of the planets, looks like. And the only way to do that is to plan and build and launch a spacecraft before you discover the target, because a comet coming in from the Oort cloud for the first time, we would only discover maybe a few years in advance, and then it comes flying past and it's visible for a few months and then is gone. So the plan is to launch in 2028, actually sharing a ride with the Ariel Space Telescope that's going to one of the Lagrange points around Earth, and that's a good place to kind of park and wait until we see a comet that's coming.
That sounds like such a cool mission to be involved in. When's it going to be launching then?
So it's meant to launch in 2028. So it's a little way off yet, but this is the first fast class mission from ESA. So from only being the proposal being accepted last year to launch in 2028 is actually a very accelerated timescale for European Space Agency to do a mission. So it's been quite non-stop planning and figuring out the details in the last year or so.
So
will continue to be so for another few years yet. So.
Have you bagged yourself a NEOWISE yet then? This is the name of the new comet.
This is the new one, yeah. So we kind of expect that most likely our target comet will actually be discovered by the LSST, the new Vera Rubin Observatory, this big survey telescope that's under construction in Chile, because this is going to scan the whole sky every few nights with an 8-meter class telescope, so something equivalent to the biggest telescopes that we currently have for detailed follow-up work, but it will be wide field imager, and it will scan the whole sky, and it's going to discover so many more comets, asteroids, supernova, anything that changes in the night sky.
Oh, exciting.
So we haven't discovered yet whether that means the comet will be called the Vera Rubin comet or not. We don't know quite yet what the policy is. Normally, when something is discovered by one of these surveys, it gets named after the survey. So that's why there are many comet pan stars, and there's quite a few comets called linear, because these are other sky surveys that have been looking for asteroids or comets. And this is why NEOWISE is called NEOWISE, because it was discovered by the NEOWISE asteroid survey.
So where does the comet come from then?
So the comet NEOWISE is also coming from this Oort cloud. So this is the same region where we think our target comet for the mission is going to come from. So the Oort cloud is this cloud of comets that sort of surrounds the solar system, and it stretches halfway out to the distance to the next star. It's really the very extreme edge of the solar system, hardly bound at all. It's so far away we can't see anything out there. Even if there was another planet out there, we wouldn't be able to see it directly with telescopes because it's so far away. But we know it exists because we see the comets coming from there, and there has to be this population of comets, this reservoir where they come from. And then you get two different types of comet coming from the Oort cloud. You get ones that are coming in for the very first time, things we call dynamically new. That's the ideal target for Comet Interceptor. And then you also have things that are kind of that have come past once or twice before, but are on these long periods that are very long by human terms, but short in the edge of the solar system. And NEOWISE is one of those. So it's currently the estimates on its orbital period are measured in a few thousand years, which is it means that it's not something that we've seen before. as people, or it wasn't recorded if it was seen before. But it is on the edge of the solar system. That's a very short period of time.
So how do you get a space mission to a project like this?
So you have to wait for the right one. Basically, you have to wait for one that's going to come through the right region of space. So it's like, you know, your cops hiding behind billboards. They can only catch the comet that's going along that road. So we have to wait until we get a good comet that's coming in the right direction and into the sort of region of space that we can get to. And then when we see that, we fire the rockets and time it right to be in the right place at the right time and see it come past.
So let's just explain what a Lagrange point is, and then you can talk about which one you're using, please. Question from Ian Baker, the guitaring astronomer.
Yes. So the Lagrange points are places where the gravitational effects of a couple of bodies balance out. So we're talking about the Sun-Earth Lagrange points. So these you have L1. This is the one that's between the Sun and the Earth. And that's where we have some solar observatories sitting there. Particularly, there's the SOHO observatory, which has discovered many comets itself, the ones that are the small ones crashing into the sun. And then the L2 is the other side of Earth, so it's on the side of Earth opposite the sun. And this is a good place to put space telescopes. So this is where the Herschel telescope is based. It's where the James Webb Space Telescope will go to. And it's where the Ariel exoplanet hunting space telescope will go to, and that's the one that we're sharing a ride with Comet Interceptor. So we're hitching a ride on that rocket, so that's why we're going. But it also works out to be a very good place for us to wait around in space, because it's somewhere where the gravitational forces balance and you can kind of maintain an orbit around there and sort of station keep with relatively little fuel.
Fantastic. So will you be setting your alarm early to go and try and see NEOWISE this evening then?
I think this evening it's meant to be cloudy in Edinburgh again, but the forecast is better for the weekend, so I'll give it a go. Okay,
so hopefully you won't get a speeding ticket this weekend. Would you like to play Comet or Bonnet?
So this is going to be pretty embarrassing.
Okay, we're going to play Comet or Bonnet with Colin Snodgrass. So here we go. Right, my word. I've got to say, I think these are tough. Right, okay. So Africano. Is it a comet or is it a bonnet?
There was a Comet Africano.
Well done. It was a 2018 Jupiter family comet.
Yes.
Excellent. Shako or Shako?
I'm going to go with Bonnet for that one.
Well done. It's a tall cylindrical military cap. What about
very educational show?
Well, what about Pimentel?
Pimentel. Yeah, I don't know that as a comet either, so I'm going to go for Bonnet again.
You would look really silly with a 2015 Halley-type comet on your head, I'm afraid.
There we go.
Homburg. Comet
Homburg.
Homburg or Bonnet Homburg?
A Homburg's a hat.
Well done, yeah. I just thought I'd put an easy one in. And Bressie. Would you wear a Bressie or would you look at a Bressie through binoculars?
Bressie. Maybe that's a comet?
Yes, you got 4 out of 5. Congratulations, Colin. Excellent. Well, I hope you have I've been thinking it was Friday all day. I've made so many errors telling people have a great weekend. It's not too early to start thinking about the weekend, though, is it? No, have a great Friday, then have a great weekend. Oh, we've got one more comment. Let's have a quick look. Will you wait for a perfect looking comet to go, or for there's a great question from Simon. Will you wait for a perfect looking comet, good looking one, hubba, or go for the first good comet you see?
So that will kind of depend on how likely we think it is that we'll have more good options. So one of the things that we're going to do over the next few years, while we're waiting for the mission to launch, is that we're going to be studying the comets that the LSST finds, and we're going to be finding out how many it finds, basically, how regularly a good reachable one arrives. And if that kind of indicates that really only maybe one in every few years is going to be a good one, then we probably go for the first one we spot that we can go for. Whereas if it's finding a few a year that would potentially be good targets, then we can be a bit more picky. So.
Well, who knew that Comet or Bonnet has got the power to cause family fights? Gillian says family fight over Comet or Bonnet. We got 3 out of 5. That's not bad. That's not bad. Well done. Well done. The thing is, last week, I can't remember what the special was. Oh, it was cosmology. And I really couldn't think of anything to rhyme with cosmology. So we didn't play the game. Colin, it's been an absolute pleasure. And hopefully I will see you around at one of these amazing astronomy events when they all come back online. Who knows?
Yeah, hopefully so.
Catch you later. Thank you very much.
Bye.
Bye. Thank you very much. That was Colin. Thank you very much, Colin. So next, I can see him waiting patiently in the waiting room. We have got, oh, he's waving his hands at me. I've got the power over Dave Eagle right now. He's down in the little waiting room. So I'm just going to have a quick chat before Dave comes on, Dave Eagle Nebula, as I'm now calling him, about the benefits of joining the SPA. It's really quick and easy to join. It will help your interest in the stars, and you will be welcomed into a really friendly community of people who all share an interest in observing or learning about the universe. The reason I do astronomy is because it is fun and I get to meet lots and lots of new friends, and new friends are so good for your mental health. They really do help you feel so much better and happier about yourself. And there's just something lovely about us as Astro types. There really is. I've got some lovely astronomy friends and we have stuck together for years and years, and everybody is very affable indeed. So you can either choose from a standard membership, which is £23 a year, the Young Stargazer, which is for those aged up to 15, or junior member 15 to 17. Both young stargazers and junior members enjoy the full benefits of membership for just £17 a year. Now, here's a great idea if you are a teacher. The same rate applies to school memberships, and we provide 1 copy of the magazine for the school and also access to our meetings for students. So get the school kids into it. Who knows, leaving. So basically, currently at the minute, I am writing a downloadable ebook about careers in space for children, space careers in the space sector for kids who love space. There is so much opportunity for clever engineers, technicians, scientists, creatives in the space sector. It's a massive, growing, thriving industry, even despite of COVID. In fact, the productivity in the space sector is 2.6 times higher than average because everybody loves their job so much. So leaving a copy of our SPA magazine around, you never know, it could change somebody's life, especially a young person's. Right, Dave Eagle, we're coming over to you. Are you ready? In 3, 2, 1, here he is. Hi, Dave.
I'm good.
How are you,
Vicky?
Hey.
I'm a bit out of breath.
Well, I'm a bit upset.
I've just run all the way from the Virtual Astronomy Club, so I'm...
Yeah, speaking of which, you've been two-timing me tonight with another comet scientist. Who have you been chatting to over on the other side?
I'm going to talk about it in a little bit, but it's the 25th anniversary of discovery of Comet Hale-Bopp.
Right.
This month. So we've had Alan Hale telling us all about his comet experiences and telling us about comets.
I'm just going to read this lovely comment here from Gillian. This is wonderful and should be emblazoned in the testimonial section of our website. The Society for Popular Astronomy is fantastic. Something for everyone's level. It's a joy. Proud to be a member. I haven't been a member long. I joined in 2017. Wonderful way to spend your money. And lest we forget, it's not actually very much money, is it?
No, I've been a member for many years. So, yeah.
Haha, check you out. Very good. Very good. Excellent. Okay. So, Dave, what are you going to talk to us about tonight then?
I'm going to talk about Comet NEOWISE, if you'd allow me.
I will allow you. On your marks, get set, chat about comets, and then you can play.
Right. So I'm going to share my screen.
Yeah.
So I should be able to share my screen. Yeah. Is that working?
Now I can kind of see that you need to go full screen with your screen. There it is. Okay, let's go.
Okay, so I'm going to talk about Comet NEOWISE, which is causing a lot of excitement. But, of course, it's a bit of a problem with the weather at the moment. So it looked like it was going to be really exciting when it came into the Soho view. This is between the 22nd and 27th of June. And you can see the comet actually coming in the field of view here. So this is the sun. So that little circle is the size of the sun, because this probe is studying the atmosphere around the sun and any outbursts. But you see just how bright the comet gets. As it comes in, you can see it's fairly bright, but as it gets further and further across the field of view up until the 27th of June, you can see just how bright it's getting. And of course, this was a week before it is at its closest to the sun, because when it's closest to the sun, that's when it gets its hottest. Okay, so it looked like it was going to start performing really well. But this time we couldn't see it. It was in the southern hemisphere, disappeared into the twilight, and then we were waiting for it to come out. Eventually, a couple of days ago, I managed to get myself up in the early hours of the morning, and there it was. Naked eye, absolutely fantastic. And it looks like it's going to perform for us really, really well. I had to go a few miles south to get away from the clouds, but that's one of the images that I took. And you see, I was fighting some of the clouds.
So, Dave, can I ask a quick question, please? Because at the minute, it just looked like Comet. It was, which was the one in the southern hemisphere that kind of left the amazing trails all over the sky? McNaught, was it?
Comet McNaught a few years ago, yeah. The southern hemisphere seems to be favoured with bright comets compared to the northern hemisphere. So it makes a change for us to actually get one that's coming north and improving, because we've had two this year. We had Comet Atlas and Comet Swan, which gave really nice displays in the southern hemisphere, and they were both heading north, and we were really looking forward to actually, there's some good comets coming our way. And of course, just as they started to appear in our skies, they all broke up and faded.
Is there a chance it might break up, or has it had its encounter with the sun then?
Well, sometimes that happens. There was some talk a couple of days ago that might be doing that, which has caused some increased activity. But the tail is looking really, really nice, and it is a naked eye object. I left it a bit too late because I set up my vantage point with the camera, but there were persistent low clouds, so I had to up sticks and jump back in the car and drive a few miles south to get the clouds a bit lower so I could get the comet. But by that time, the sky was really bright. But this weekend, it looks like we're going to get dark skies. But I'll tell you the circumstances of the comet. So just a couple of the images that I took while I was there. So to help you find your way around where the comet is, this is the view towards the northwest sky just before sunrise. Okay, so as dawn's approaching, and you'll find the bright yellow star Capella here, and you can identify that by this triangle of stars here known as the Kids. Okay, that's in the constellation of Auriga, the Charioteer, which is a kite-shaped constellation, something like that. But the two brightest stars are Capella and this one here. So they're going to help us find the comet. And if you can look really carefully, can anybody see the comet in the picture? Well, I'll give you a clue. It's here. So that's where the comet was, just above the cloud there. And that was a couple of days ago, but it is on the move. It's heading north. So that's where it was on the morning of the 6th of July, 9th of July. So it's about there at the moment. So it's moved up quite a bit. And then on the 11th of July, it's going to be dead in line with these two stars. So if you find Capella and find this star lower and to the left of it, it's going to be in line with that. So that'll help guide you to where the comet is. But if it's anything like it was on the 6th, you're not going to miss it. And some of the pictures that people have been sending in the last few days have been fantastic. So that's the sort of path it's following across the sky. So it's heading north. And at the moment, if you're in the northern part of the country, it's circumpolar. But it's only just above the horizon. Okay, perihelion closer to the sun was actually on the 3rd of July. But it's actually getting closer to the Earth at the moment. So on the 23rd of July, when it's at its closest to Earth is when it's going to be its brightest if it doesn't break up. Okay, because the proximity to Earth dictates how bright it could be. And that's quite a significant date because that will mark the 25th anniversary of the discovery of Comet Hale-Bopp on the same day, which is quite surprising.
Lovely.
And it's 103 million kilometers from Earth at that time. And at the moment, it's easiest in the morning before 3:30, because by about 3:30, the twilight's getting really bright. And I just managed to rattle off some images before it started getting lost in the twilight. So, you need to go out before 3:30. So it's a really early morning for people, but it's well worth it, tell you. And because it's getting higher in the sky, it's going to be visible in evenings as well after sunset. So you're going to get 2 pops at getting the comet. So early July, it's going to be visible low in the northeastern morning sky, which is the view I got on a few days ago. But go out before 3:30. But because it's getting slightly or slowly higher in altitude, so it's getting up a little bit, from the 10th of July, it'll be visible in the northeastern morning sky as it has been, but it'll be a bit higher. But it'll also be visible low in the northwestern evening sky after sunset. So if it's clear in the evening, get out and have a look. Okay. And if it's clear in the morning, also get out and have a look, because you'll see how the comet changes. And people have started to show it's got an ion tail forming now, very much like Hale-Bopp did all those years ago. So this is the path of the comet. So you can see it sort of swings round in a big loop. So here, down here is Orion. This is Betelgeuse. And here's where the comet currently is here, just to the left and lower down from Capella. Here's Capella and that other bright star. So it's going to move upwards in this direction. So by mid-month, it's going to be here almost at Lynx. Everybody knows the constellation of Lynx. Surely it's very, very, very bright. No, it's not. It's very indistinct and nobody really knows the constellation. These will guide you to, use these 2 stars to guide you to the comet, because, it's moving around in this direction, but you can still use those to go left and then up slightly. So on the 23rd of July, when it's at its closest to the Earth, it's going to be directly below the Plough. Here's the Plough in Ursa Major, the Great Bear. So the 7 stars of the Plough. So it's directly below the Plough. And it should be visible all night because it will be circumpolar by that time. And then by the end of the month, it's going to be in Coma Berenices amongst all the galaxies there. So hopefully we get some nice shots of it with some galaxies in the background as well. That should be quite nice.
Oh, do you know, I've got goosebumps looking at this. We are so overdue something lovely, and it's lovely just at the end of lockdown, a nice little reward for our patience, isn't it?
Yeah, definitely. And then that takes me back to the time all those years ago in 1995 when I was on holiday in Portugal at the Centre for Observational Astronomy in the Algarve. And Bev, who runs it, came in at dinner time and said, "Oh, there's a new comet been discovered. Shall we take a picture of it?" I went, "Yeah, okay." And here was that really fuzzy picture that we took all those years ago, which turned out to be, of course, Comet C 1995-01 Hale-Bopp.
You've got Hale-Bopp's baby photographs.
Baby photograph. And of course, that was discovered 23rd of July, so 25 years anniversary. Yes. And that was discovered by Alan Howe and Thomas Bopp. Unfortunately, Thomas died a few years ago, but we were lucky enough on the Virtual Astronomy Club to have Alan talk to us tonight. And of course, this is my picture that I took back in 1997 of Hale-Bopp when it grew up.
Oh, look at you all grown up. Haven't you grown? Look at your length of your tail.
This beautiful ion tail and the dust tail. So it was absolutely wonderful. So let's keep our fingers crossed that NEOWISE is going to give us a similar sort of display, because it is developing an ion tail now on some of the pictures that people are posting now.
Dave, just explain what an ion tail is, will you, my love?
Okay, yeah, I'll do it on the picture here, which I've still got up. So you've got the dust tail, which is made up of the bigger particles, the dust contained in the comet. And you've also got a tail that's made up of gas. So it's more volatile than the dust tail. So there's much smaller particles. So what happens is, as the comet's moving through space in its orbit, because the dust particles are going much, much slower than the ion and the gas particles, the ion tail is normally a lot straighter. As you can see in Hale-Bopp's image here, the tail is a lot straighter, but the dust tail, because they're bigger particles and move slower, they tend to get drawn out into a curve as the comet's moving along its orbit. Okay, so they're just different. And you can see in Hale-Bopp, we can see there were 2 different colors as well. The dust tail is more of a golden color, and the ion tail, the gas tail, is more blue.
That's fantastic. And I actually didn't know about why the 2 tails were slightly different. You've got an excellent knack for describing things. Is that the end of your presentation, Dave?
Well, I'm just going to talk about the Virtual Astronomy Club. We did mention it at the beginning. So we had...
You're allowed to You're allowed to plug away. We were only talking yesterday when we were doing our little test about how live streaming is really, it gives you something to look forward to all day, because you've literally got to produce a TV show for yourself, haven't you?
Yeah, almost. Yeah, I've got to find speakers to fill it as well, but it's been great fun. So it has given me something to concentrate on. Yeah, it's on. So if you go to the website, star-gazing.co.uk/VAC, and you get all the details on there. And I give you an idea of the sort of speakers we've had. We've had Robin Scadgel from the SPA coming in to talk to us a couple of weeks ago. Next Tuesday, we've got Ian Ridpath telling us about pictures in the sky. And then on the 21st of July, because the planets at their best now, they're not at the best for us because they're so low down in the sky, but Jupiter's at opposition and Saturn's at opposition this month. So we're going to do a webcam planet and moon imaging. I'm going to be showing some of the things that I do to get my planet and moon images, and hopefully get people out there and doing it, which is great fun.
Okay, so we've got some questions here. One from Simon.
Okay.
When would be the best time date to get the kids to see it? Yeah, you don't want them getting up at 3 a.m. That'd be a horrible day the day after.
Yeah, I'd wait a week or so until it's visible in the evening sky, and then make sure you've got a really clear northwest horizon, and then find Capella, because it will be visible, and follow that line down, and you should see the comet below and to the left of Capella.
So we have got Gillian here saying, thank you, Dave, for your help trying to locate NEOWISE. Hopefully as many of us as possible can see it, photograph it. Just need the rain to stop.
Yeah, well, Friday, Saturday is meant to be getting better. So yeah. Friday night, Saturday morning, hopefully we'll get out there again and get a look.
In fact, the cloud cover has been so heavy recently that I haven't consulted my app, which is called Clear Outside, which is the astronomers app, isn't it? And it's free.
Yes.
And it's got an hour by hour, very precise breakdown of low, medium and high cloud. And it's uncannily accurate for days in advance. When it was the Mercury transit in sometime this year, I can't remember the precise.
That was the 11th of November last year.
Was that when it was? Was it in November?
It was November last year, yeah.
Good Lord, well remembered on that date. And it knew that it was going to be 60% cloudy in Delamere Forest, which is where we observe for mid-Cheshire. About 4 or 5 days in advance, it knew there was going to be a break in the cloud there. And I was the only person in the region who saw it. So Clear Outside, free cloud cover app, absolutely brilliant. Literally get it on your phone.
Yeah.
And then we've got Dave Graham. That name rings a bell. Do I know you, David? First saw Hale Bopp in August 95 with a show off 36-inch refractor at the Lick Observatory in California.
Yeah, and if you remember looking at the coma in Hale Bopp, was the most fascinating thing I'd ever seen. It was like a lawn sprinkler. It was a spiral shape, and it was absolutely beautiful. Oh, if only I had the imaging technology I've got today to be able to capture that. But you never know. NEOWISE might give us some interest in there.
NEOWISE is going to be a very well photographed comet, I do believe.
Well, it will be, yeah.
So, Dave, thank you so much for coming on today. I think the last hurrah of this evening's Comet special is Comet or Bonnet. Are you ready?
Oh, no. I wasn't looking forward to
this. You were or weren't looking forward to it? I didn't catch what you said then. Say again. Okay, Comet or Bonnet? I've tried to choose one with amusing names. So what about Klinkenberg? Would you wear it or would you observe it? Comet or Bonnet? Klinkenberg.
Bonnet.
You are completely right. It is. No, I'm sorry. You're wrong. It was a 1748 comet.
Oh,
was that right? Do you know what? That doesn't sound right. No, Klinkenberg was a comet in 1748.
I wasn't around at the time, so I don't remember that one.
Nice, Klinkenberg. Okay, what about right? This is spelled U-P-E. I'm going to pronounce it Uppe. Oop. What's Oop? U-P-E. Comet or Bonnet?
Let's say Bonnet.
It's a headdress made from straw. What about Hartwig?
Artwig. That almost leads you to say it's something you wear on your head, doesn't it? But I'm going to say Comet.
It was an 1879 Comet. Well done. What about Ushanka? Comet or Bonnet?
Go for Bonnet.
It's a trapper hat, a fur trapper hat. You know, the ones with the flappy ears.
Thank goodness for that.
Oh, thank God, thank goodness. And the final one, was it a comet or is it a bonnet? Pork pie.
That's a hat, of course, yeah.
There was never a comet pork pie. But there should be. Maybe one day, or in a parallel universe, a pork pie discovers a comet and we get a comet pork pie.
Yeah. An asteroid named after a pork pie, you never know.
So, Dave, I hope it's not Friday. I keep telling everybody, have a great weekend. It's Thursday.
Mind you, it's Blur's Day because one day blurs into another.
Blur's Day, yeah. Oh, tell me about it. Tell me about it. Well, Dave, thank you so much and well done for supporting the SPA and doing all your other amazing virtual astronomy stuff. Is it on Tuesdays, did you say?
It's Tuesdays now. Yeah, we did do Tuesdays and Thursdays, but on July we switched to just Tuesdays. But because Alan could only make Thursday this week, we did Thursday this week. So Tuesday evenings, the Virtual Astronomy Club. Come and join us. Everyone's welcome.
Give us in a couple of sentences why the SPA is so great and why people should join.
Because it's accessible to everybody. You know, it's something in the magazine for everybody. And it's not full of stuff that sort of you look at and go, oh, it's gone. No, sorry. Yeah. It uses people, get people involved. And that's what we want with astronomy, is get people involved and get them out there and doing it. That's what it's all about. Such
a wonderful hobby. It's so good for your mental health. And have you made lots of friends through the SPA?
Not that many, actually.
Oh,
only recently, because I've not attended many of the meetings, I must admit, because they've all been down in London. But since they've been going virtual, then I have.
That's great, isn't it? Yeah, I've met a lot more
meetings
people.
Have gone, and you know, that's one thing that I found with the virtual things that I do. It allows you to get people involved who perhaps wouldn't be able to travel, wouldn't be able to go anywhere. So, you know, people who are housebound or whatever, they can still get involved. And that's what I've really been impressed with the virtual stuff, which I probably wouldn't have considered before. So although I started the Virtual Astronomy Club because of the lockdown, I think we will continue with it going forward as well. So it's been fantastic. And I've made lots of friends as a result of that and got involved with the SPA as well, and yourself, of course.
Me and you, yeah, we wouldn't have known each other very well. We would have just been friends on Facebook, really, wouldn't we? So, okay. Oh, I don't think I've had a drink this whole time. Have you got an SPA mug, my love? You need one.
I've got
Love you to the moon and back. Well, I love you NEOWISE and back. So I'll see you later, Dave, and I'm going to sign off now. It's been a pleasure, everybody. Like, tag, share this video. Share the video. We're going to go now. See you later. Thank you, popular astronomers, and good night.